and welcome to today's webinar, IoT Security, Mitigating Security Risks in Smart Connected Environments. Hello, my name is Randy Vanderhoof, and I'm the Executive Director of the Secure Technology Alliance, and I'll be the moderator for today's session. Today's webinar is being recorded and will be available for playback along with a presentation deck after the webinar has concluded. There will also be time at the end for some questions, so I encourage listeners to submit their questions using the user dashboard on your screen. I will return at the end of the presentations to lead the question and answer period, and I encourage you to submit questions while the speakers are presenting so that we have time to organize them in advance and so we can get to as many of them as we have time for. So if we can go to the first slide. For those of you who are not familiar with the Secure Technology Alliance, here's a brief overview. The mission of the Secure Technology Alliance is to work to stimulate the understanding, adoption, and widespread application of secure solutions. And we do so by providing in a collaborative, member-driven environment, education and information about how smart cards and embedded chip technology and related hardware and software can be adopted across all markets. On the right side, you see the markets that we focus our attention on, which include access control, authentication, healthcare, identity management, Internet of Things, mobile payments, and transportation. And today's focus, obviously, is going to be about the market of the Internet of Things. What we do to bring industry stakeholders together for this collaborative, member-driven environment is to publish white papers, webinars, workshops and newsletters, position papers, and produce content that we distribute through the internet. We also create conferences and events that focus on special markets and technology. We offer education, training, and industry certification programs and provide networking opportunities for professionals to share their ideas and their knowledge. If we can go to the next slide, please. IoT security is one of the many technology and industry verticals that the Secure Technology Alliance focuses on. These councils attract like-minded companies and individuals to identify and address priorities that will have an impact in accelerating adoption and growing the size of the market, such as focusing on secure architectures that incorporate embedded security and privacy, providing a forum for intra-industry and cross-industry collaboration to discuss things like secure IoT architectures, provide business-focused organizations to discuss best practices and implement IoT architectures, become a single voice for the industry to share information and experiences and discuss applications and security approaches, and to identify and collaborate with other organizations to define and promote standards for secure technology architectures. On the right, you see one of the ways in which we communicate, which is a web information portal. And that's called the IoTSecurityConnection.com. And on that site, we have a number of publications that we have contributed or that we've garnered from other sources in the marketplace. If we go to the next slide, please. So let me introduce you to today's IoT security presenters. So we'll begin with Sri Ramachandran, who is the Vice President of IoT and Solutions at G&D Mobile Security. And Sri also serves as the chairman of our IoT Security Council. Joining Sri, we have Steve Hanna, who's Senior Principal at Infineon Technologies, John Neal, Business Development and Government Affairs for NXP, and Josh Jobs, who's VP of CTO of IoT Solutions for Entrust Datacard. All four of these presenters and are IT experts within their organizations and are experienced industry leaders who are highly sought after presenters at industry conferences and often quoted in leading industry publications. Next slide, please. So we'll begin today's webinar with a presentation on Intro to Security IoT or 101 rather for IoT, and Sri Ramachandran will be giving that presentation. So Sri?
Thank you, Randy, for the introduction, and thank you for the kickoff. Thank you, everybody, for joining today's webinar. I'm just going to present the context for what security means in IoT. So next slide, please. So we've all heard of the coming onrush of these connected devices or IoT devices. So I've taken this report, which is perhaps almost a year old, from Ericsson, and they actually publish this quarterly, but this is a good graphic to show what they mean by connected devices. So connected devices can be many different things. I mean, your mobile phone is also a connected device. But clearly, the way the distinction happens is the devices that are not, that don't have a human on the other side, is considered IoT device. And in general, everything is going to be a connected device. So even in the case of PCs, laptops, and tablets, we're going to have the next generation of what is called an always connected PC that is going to be the wave of the future. So overall, what this is really showing is that there's going to be a tremendous increase in the number of connected devices overall. And even if you look at the IoT devices, essentially those that are devoid of a human interaction with it. So they are broadly classified into wide area and short range IoT, and even in that, there's going to be a significant increase in the number of those devices. Now, what usually happens when you have such a plethora of devices is that you have new services that can be defined, new services and use cases that come into play. And anytime there's a new use case, there are many ways to create business models around them. And so we're going to see new business models. And unfortunately, every time a new device or new type of device comes on the market, there are new ways to hack into that. And so the number of security threats for those devices only increase. Next slide, please. So we all understand broadly what the nature of risk is, right? Especially when it comes to a business context. So we understand business value, and we understand if a device goes offline due to whatever wear and tear, problem with it, with its maintenance and so on, that it constitutes a definite business risk, right? But security is pretty interesting. So how do you correlate the risk due to security threats against the business value, right? So this is one of the conundrums of the whole IoT security, of the whole IoT industry in general. So you may have a very low-cost device that's providing a very critical sensor data that may be for, let's say, if you look at the highest value objects that are represented here, which could be, a jet engine, or it could be a very expensive MRI machine. It may be a small sensor that goes awry, but that gets hacked, but it's sufficient enough to actually create many deleterious effects downstream, right? So how do we actually solve for this? So this actually makes the creation of scalable security solutions really hard, because we've got to have security solutions that scale to the most expensive devices to the least expensive devices, and you cannot have any device that cannot be secure. Next slide. So we want to make this interactive, and what we have here is a poll. The poll is open to everybody in the audience, and it's a simple question. So if you have a connected baby monitor, which costs, let's say, about $100, what do you think the risk of that being compromised is? And we wait about 20-25 seconds for the folks to vote. So this is this is to illustrate the conundrum, right? So it's not that expensive, but if it gets breached, it is the most terrible thing that can happen. So let's look at the. Okay, so in general, people feel that 2/3 of you all think that the risk of that being compromised is fairly high. So an interesting stat I want to mention is that the connected cameras are one of the most deployed IoT use cases. So there's probably over 1 billion connected cameras deployed worldwide, and due to they're used for surveillance, security monitoring, and so on. And so these are the ones that are provide a lot of scope for being hacked. Let's go to the next slide. So the last year or 2 years, we've seen a lot of these headlines where we don't know. I mean, it's been a general threat of cyber attacks, so we don't know whether it's an IoT or not. So there was the hackers who remotely got into hacked the Jeep while it was running on the highway, and that was just to demonstrate that it could be hacked, fortunately. And then there are the attacks, overall attacks, which are actually across the whole industry that's being widely watched. And there are these famous ones. The first one was the breach in the Target stores, which was through an adjacent network that was connected, that was actually connecting all the IoT devices. And then there is this WannaCry ransomware, which actually affected a lot of both IT and IoT devices, right? And then you have the inverse of those, where we have this Brickerbot malware, which actually goes out and destroys unsecure IoT devices. So there's essentially a huge mess where people are working to create bad things as well as create good things to destroy bad things. But it gets more interesting as we see in the next slide, that it's becoming more and more IoT focused. So this phishing attack, as we call it, it's where we had criminals hack a fish tank to steal data from a casino. And then we see that in general, there's 80% of IoT devices have some kind of security flaw and can be hacked into. And there's the other more recent one where the city of Atlanta suffered a major cyber attack, and they haven't revealed what exactly caused it, but it's something that they're still recovering from. So these are very powerful headlines that actually wake us up and make us think that we can be hacked anytime. Next slide. So we go to the second poll question. So given that all these attacks are happening, do you think your company is adequately protected against cyber attacks? So I think most people think that they are somewhat protected, but I think there are probably security companies who think that they know how to figure and be attack proof. Okay, so that's a great thing. So we don't have a completely cyber attack proof company yet. That's great. So let's go to the next slide. So this is a study organized by this company called Hanuman. It's actually an institute, Hanuman Institute, which does a survey of CIOs and try to understand what kind of impact a potential security breach would have on companies. And they interviewed companies of various sizes, from small, medium enterprises all the way to large ones. And the big headline I show here, where it's companies with less than 5 million in company revenue, right, is there are 2 points here. One is that about 2/3 of companies kind of belong in that category of a small, medium-sized enterprise, right? And so they usually have no IT staff, or even if they do, they're either part-time or contract. So when in that sense, they're not going to have a way to keep their networks protected all the time due to lack of personnel. And so when even in those cases, they believe that a security breach will cost about $250,000 on average. But across the board, what you find that is 76% of CIOs expect that there would be a serious attack within the next 2 years, which is very sobering. And that 94% of an attack like that could be catastrophic for their business. So it's really sobering to know that that these threats are so upon us, and we have no real way to protect ourselves. And we're looking at a very bad effects on the business overall, and loss of privacy and data on this. Next slide. So one of the reasons why we find it hard to be able to secure IoT is that overall setting up an IoT end-to-end system is fairly complex. There is a whole bunch of different types of connected devices. Could be a connected car, a windmill, a connected medical device, many different sensors, connected GPS trackers, connected agricultural sensors, and so on. And the thing is, they all use different types of networks to actually attach themselves to send the data out, right? So if you look at nomadic devices, they typically tend to use, cellular networks such as LTE, Cat1, Cat-M, and the new narrowband IoT networks. Then you have the more smart home, smart enterprise type of devices, which actually are connected to a Wi-Fi and eventually a broadband infrastructure. And then you have a largely dispersed set of sensors, probably in an agricultural setting or in a mining type of setting, where they're using some form of low-power wide area network that's going to use, essentially free spectrum to be able to backhaul the data, right? So there are many, many different ways, and you got to allow for those devices to be able to connect to those networks too. And if you look at the number of stakeholders who are actually interested in providing some kind of service to those devices, so there's the enterprise themselves who actually want to leverage the data, but the data is going to get aggregated in some cloud platform, which could be run by Amazon or Azure. It could be some kind of private cloud also that's owned by the enterprise and used by the enterprise. And then there are the OEMs. The OEMs are those that actually manufacture those devices, and they have an interest to make sure that the configurations on those devices are kept up to date, and that with the long lifespan of those devices, some of them are expected to last 10 to 15 years. They have to make sure that they're able to service those devices over the entire life cycle of those devices. So the OEMs have a clear stake in making sure that the connected devices have a role to play, and that they're able to reach them to actually remotely service them. So these are all the different stakeholders that need to come together, and these are all the different things that a systems integrator has to do to actually put an end-to-end IoT system together. So there's a lot of complexity, and I've been in projects where it took 9 months of work between 9 months of work after the project got initiated when the first data actually flowed end to end. So clearly there's a lot of work and a lot of complexity involved in these things. Next slide. So when we have such complexity, where do we feel that the security challenges are? So I broadly put them into 3 buckets. The first one is device security, which is the security posed by the firewalls and the other things that go into the device itself, right? And how the device itself can be made secure. The second is device to cloud security, where we enable the device to be able to be recognized by the cloud and to know that the device is sending data only to the cloud, and to make sure that the data going from the device is securely encrypted from the device all the way to the cloud, and that there's no way to hijack any of the streams going through, coming out of the device. The third is operational security, which involves looking at the entire life cycle of the device and making sure that firmware updates are actually sent down to the device, that the devices can have some way to actually service them, put them into maintenance mode, and how we can actually make things more secure. So next slide. So I'll quickly give the list of the challenges of IoT device security. The first one is to make sure that we can identify every device in the system, that every device is operating as planned, that we're able to protect the data that is being gathered, and then to have secure management and monitoring throughout the life cycle of the device. And as I said before, to provide differential access control so we know what are privileged and what are regular operations of the device. Next slide. The device to cloud security has further issues because we have IoT devices that don't have username and passwords. So the traditional means of authentication don't work here, and so we have to devise other ways, and it's usually using keys and certificates that the devices are able to identify itself to a cloud, and we got to make sure that the cloud can do mutual authentication of the device, as well as make sure that the encryption of all the data from the device to the cloud happens. Next slide. So overall, I think there are 4 things that we want to talk about. So what the market really needs is to put in the root of trust, so we can do irrefutable identity management of the device. All data is encrypted between the device and the cloud, and we can prevent malware and rogue configurations, and we can recover stranded devices so that if there is an error or some kind of software error or a configuration error, we can actually recover stranded devices. Next slide. So how do we do this across all of the IoT devices? Because IoT devices are, there's a whole wide variety of them. And what we want to do is define what we call a control plane, where you have these common functions that enable the lifecycle management of those devices, which is independent of what the actual use case is determined to be, right? So whether it's a jet engine or a simple monitoring of a pump, we can still have the same control plane that can actually do the lifecycle management for the device. Next slide. So this is a case study that I wanted to do, but what I'll really talk about here is that there are 3 things that we talked about before: the device security, which is considered here as a security framework that enables secure manufacturing, and the flexible connectivity allows for a secure device to cloud security for the manufacturing of those cars, and then the secure production enables the entire operational security of the end-to-end flow. So with this, I want to hand over to my next speaker, Hanna. Next slide.
Thank you, Sri. So I'm going to talk about industrial IoT security and also about financial IoT security. Next slide. Before we get into that, here's a polling question for you. Which type of IoT are you working on securing? Is it smart car, smart city, smart home, smart factory, or something else? You can actually check multiple if there are multiple different kinds of IoT that you're working on securing. All right, let's see the results here. Very interesting. So one of the things that we see here is a lot of other, and that just illustrates the broad range of IoT, the many different types of things that are being connected. Next slide. So first I want to talk a little bit about industrial IoT. If you're familiar with how industrial systems are set up, there is, of course, a plant, some sort of field level where actual actuators and motors and conveyor belts and the like might be located. Then there's a control level, which provides real-time controls, supervisory, and up to the plant level. What we do with industrial IoT is that we connect these things to the cloud in a controlled manner. Next slide. By doing so, we're able to achieve several things. First, what's called lot size 1 or Industry 4.0, the ability to mass produce individualized products. Instead of, as Henry Ford said, any color you want as long as it's black, every car can be a little different. Every widget that's manufactured, built to order. And with additive manufacturing, this can really be quite radical. With cloud services, we're able to bring the intelligence of the cloud, deep learning, big data, and other things to bear on the manufacturing environment to optimize and realize cost reductions across different settings. We're able to enable new business models, such as pay-per-use or predictive maintenance, and to enable the continuous innovation that cloud provides. And all of this is enabled by fundamental advances in technologies, such as lightweight sensors with long-lived batteries that can be just stuck onto devices with a little bit of glue. You don't have to run wires. You have wireless networking. And we have inexpensive cloud intelligence. So all of these fundamental innovations add up to the smart factory. Next slide. In the world of payments and finance, we also see IoT-based revolutions. Next slide, I have a few examples. For example, it could be wearables, a smart watch or a ring that a user can use to make a purchase conveniently, just tap and go. Or there may be no human in the loop, actually. Perhaps your refrigerator is ordering refills for the milk and orange juice as needed, or your dishwasher ordering those rinse agents and detergents, or your smart meter not ordering but providing billing. This pay-per-use model can extend beyond things that we've always paid for in pay-as-you-go mode like electricity, and into all sorts of new applications where you may pay as you go. We have predictions that connected devices will initiate more than $1 trillion in transactions by 2020. And with the massive amount of orders coming through smart speakers, I don't doubt that that's true. Next slide. But we have to consider security. And one of the questions that I often get is how much security is needed for a particular IoT application. The answer, of course, is that depends. It depends on the level of threat, the level of risk that you're encountering. And Sri did a great job pointing out earlier with his poll question that it's not based on the cost of the device necessarily, but what could go wrong and what are the motivations of the attackers. So we see that there's a whole scale from no security needed up to requirement for protection against the most sophisticated attacks. And this scale is something that you see in the international standards, as mentioned on the bottom of this slide, IEC 62443 for industrial security. And you see it in guidelines and best practices across the industry. There's no one-size-fits-all solution for IoT security, but in any case, and in every case, it needs to be considered carefully. Next slide. So I'm going to talk to you about a real-world attack that took place a few years ago in the Ukraine. For more details, you can follow the link at the bottom of the slide, which has a well put together analysis and description of the attack. Attackers were able to break into 3 of the regions of the Ukrainian power grid and shut off power for more than 6 hours in the middle of winter to 250,000 people. So I'm sure it was a cold night for those folks, and a dark one as well. How did they do it? Well, they started by coming in with a spam email, targeted spam, what we call spear phishing. Through this, they were able to infect a business PC and to spread within the IT network. Now, often it's the case that the IT network and the OT network, or operational technology network, are connected, and that was the case here as well, but with a firewall. It's common practice, and people use this to be able to do remote administration, or simply to connect the OT network back to the cloud. But in this case, they were able to get credentials that allowed them to get through the firewall and, in fact, to use the VPN. With that, they were able to take advantage of many vulnerable nodes within the operational network, such as the workstations where they installed malware, and even the breakers, which themselves were not computerized, but which had serial to Ethernet converters, which they were able to hack. Then they could flip the breakers, disable the serial to Ethernet converters so nobody could flip them back, and wipe the disks on the operator workstations. It was a long night there in the Ukraine. Next slide. So how do we stop this sort of attack? Well, there is no single silver bullet. What we see here are a variety of different approaches and techniques that can be used. I won't have time to go through all of them today. For more details, you can look at the link at the bottom of the slide. But I will mention a few, which were touched on earlier. Strong authentication of devices and users, secure communications, protecting against eavesdropping and tampering with the communications, boot process protection to make sure these devices boot securely, and secure software and firmware update, which is essential because no software is completely without bugs, and we have to have the ability to securely update them. All of those, and in fact every protection on this slide, is dependent on cryptographic keys. Those are the bedrock of our IoT security solution, and so they need to be well protected, and for high security or high risk environments, generally protected with hardware root of trust. Next slide. If we look back at the Ukrainian power grid, how could these defensives have helped us? Well, in the first place, the business PC, the credentials that would be used there would be cryptographic credentials, not passwords. And if stored in hardware, could not be stolen by the attacker, so they would be unable to get in through the VPN or through the firewall because they would not have the hardware token needed. In addition, vulnerabilities on the operator workstation can be mitigated with hardware security, and likewise in the breakers. You have to make sure that you keep these things well protected. Next slide. I'd like to end my section of the presentation by talking about the value proposition, or you could say the business case for IoT security. It rests on 3 fundamental pillars: reliability, safety, and cost. These are things that every business needs to be concerned about. And in order to protect those 3, which, after all, we're hoping to improve with our IoT systems, we need to make sure that proper security is in place so that uptime and reliability and quality are maintained. We avoid excessive risks, potential brand damage, or even injury to individuals, and we keep our companies on a steady financial course. This applies not just to the end user, but also to the equipment manufacturer who could find their reputation damaged or even suffer some financial impact if there was a successful attack on the systems that they have created. Next slide. And now I'd like to hand things off to John for the next section of the presentation.
Thank you, Steve, and thank you everyone for taking time out to join this webinar today. As part of my presentation, I'd like to talk and describe a couple of use cases for you regarding the IoT and security, how NXP thinks about these things, and some regulation and how NXP and some of our partner companies are dealing with different regulatory regimes that are being rolled out in Europe, and we're seeing things in the United States. Next slide, please. So the first thing I'd like to talk about is connected cars, use case around that. And you know, as we see cars and automobiles and how they've evolved, especially over almost the last 50 years now. You know, my first memory of riding in my grandparents' Chevrolet Impala, you know, you had some gauges, a few electronics, but they were compartmentalized. They were unconnected. And as we move to today, 30, 40 years later, you know, more and more digitized, more computers, more electronics in vehicles. And now we see vehicles running hundreds of millions of lines of code, hundreds of processors, different sensors, all sorts of different integrated circuits, microcontrollers. Cars have become almost essentially, as some of our folks say, smart cards on wheels. And we see in the future using your car to do payment activities and authentication. You know, again, today you're familiar with the navigation, the infotainment, and the software, various software that you use to drive and sort of enjoy the ride, whether it's with you and your family. But tomorrow, again, autonomous vehicles will require, you know, as we move to autonomous vehicles, will require even more connectivity to talk to each other, as well as the infrastructure, the roads, the traffic lights, all the different safety features as we move towards fully autonomous vehicles in the future here. And as we think about that, security is paramount. There's really no difference between safety and security now as cars become more digitized, more automated. And three things, features that new vehicles will have to include going forward is, you know, the physical access, security around that, securing any personal identifiable information and confidential information that you may use to whether register yourself in the vehicle, authenticate, take advantages of different infotainment services, etc. We'll want to secure that personal data, as well as, again, your critical safety systems, whether it's the braking systems, airbags, different radars, and communication systems that the vehicle will use to, again, talk to other vehicles or to the infrastructure. Next slide, please. And as we think about that, we are looking at security as a sort of a 4+1, a layered framework for the vehicle that begins with your secure access to the vehicle, as many of us now have the key fobs that we use to unlock and lock the vehicle. And more higher end vehicles now have even different features, whether it's using a card, a fob, or a different type token to access the vehicle. The next feature then would be, the next layer rather, would be secure processing, and that would address the various control units that implement all the features that on the connected car, whether it's the driving, the infotainment, the different reporting mechanisms that you would see on your dashboard. The next framework would be then the secure network, which provides a secure communication between the different electronic control units inside the vehicle. Third layer is what we think of as a secure gateway, which provides domain isolation, basically providing some compartmentalization among the different systems in the vehicle, whether it be infotainment, your safety critical systems, your driving systems, mechanical systems, etc. And then the last layer being the secure interfaces. Basically, if you think of IoT and edge devices, the interfaces which connect the vehicle to the external world. So would be, again, in an autonomous vehicle world, communicating other vehicles as well as the roadside infrastructure. Next slide, please. And as Steve touched on hardware-rooted trust, we consider that to be essential as well to the autonomous vehicle and the connected car sort of use case. And really, it helps users incorporate security at the design phase, with the secure boot being sort of what we think of as an unbypassable mechanism where developers can sort of lock down their code into the chip or the system that they're designing. And again, as Steve mentioned, the key to the bedrock of that is the cryptographic algorithms. And the way it would work is that when each time the system boots up, the processor, whether it's made by NXP or any other chip company in the space, it validates that signature that the developer wrote to that hardware, so that only the authentic software is executable. Now we think of, again, the security by design at the design phase when we think of hardware root of trust, but we also have to think of, security, the security life cycle and the entire life cycle of the product. Knowing that a vehicle is going to be on the road and being used for years and years, 8 to 10 years now, I believe, is the average, and we see that even growing further. So it will be important to develop these tools, these systems, and with the thought of designing security in at the beginning, but also how are we going to patch software, how are we going to maintain security throughout the life cycle of that vehicle. Next slide, please. Then I'd like to also move to a use case of the smart cities use case around parking and long-range RFID. So now with smart cities, and even today, many of you, I'm sure, use an Easy Pass token or some sort of card to pay tolls, especially those of us who may live in urban areas or use various interstate highways. It's been a fantastic benefit to bypassing some of those long lines that queue up at the various toll junctions. And with long-range RFID developing and coupling that with contactless authentication and payment technology, and then adding in various rewards and incentives in the form of additional software applications to a RFID token, we've been able to design RFID tags that we can embed into license plates or to the vehicle that can be automatically read and allow for the payment to occur, making and streamlining the process for tolling and parking and functions much less of an impediment for the customer. And that's really a factor of maturing RFID technology, the EMV regulations that have gone into effect in the payment industry, and then contactless technology as we think of smart cards. But again, as Steve mentioned earlier, the bedrock is that secure cryptographic authentication, which has been developed and refined as a result of new requirements from the banking and passport industries. We also see, again, additional requirements as a result of GDPR, and then other aspects that customers are desiring around bring your own device. So very important to have these technologies be able to address multiple use cases, multiple form factors. Next slide, please. So I have two quick poll questions I'd just like to ask. If the first one being, has your company been affected by regulations such as GDPR? That's probably the most well-known new regulation that is really affecting quite a few companies, but also I believe within the last week or so, California has passed into law Consumer Privacy Act that's designed to protect consumer data. So just curious whose companies have been affected. So yes, quite a bit. And then we'll move on to the second poll question. So as a result of the regulation, does your company see a need to advocate for some policy to establish baseline standards that would help, design security into your products and services that you're selling? Okay, and we can close that. Very good. I think next slide, Kathy. So we at NXP have certainly seen that, being a company that's based in the Netherlands but has a presence here in the United States. Obviously, GDPR has had a large impact on us, even though we are not, one of those typical high visibility consumer data companies. GDPR, and I'm sure the California law will have a significant impact on our business. And as a result, NXP has partnered with several companies within what we think of different aspects of different sectors of critical infrastructure to develop what we call a charter of trust around the Internet of Things. And really, it's right now probably a more, as you would think, political type document with principles, but we are advocating for baseline standards of security for IoT products and services. And the reason really at the end of the day for that is the risk to our business if one of our devices or products were compromised, or if someone in that particular industry's devices or products were compromised and therefore caused customers to shy away from buying any similar product. And so while one can debate whether there's a floor or a ceiling to the risk of a compromise, as Sri sort of laid out, that's for each entity to sort of to determine for their risk profile. The reputational risk, to any companies and that ecosystem is quite high when you see something like a Mirai botnet or another, hack to an Internet of Things device. And therefore, we feel that it is in the industry's best interest to be forward-leaning with government and talking to them, about regulations, about baseline standards for how security for these IoT devices and services and products should look like. And we'll continue to talk to governments, and I would just leave you with that thought of how your company would want to address government and the regulators proactively versus having to deal with, the fallout of a compromise to your device. With that, I will turn it over to Josh Jabs. Thank you.
Great. Hey, thanks, John. So I see we have about 9-10 minutes left in the webinar. This last section is a little bit of a tips and tricks, so I think there's some good reference material here for those that are just starting their journey into some of this. And so in order to leave a few minutes for Q&A, I'll go a little bit quick through here, but what we'll look at is, what's unique, specific to the IoT environments, some key considerations and which will lead to essentially mapping some of the concepts that each of the presenters have talked about here, and then a couple of references to specific documentation to get started. So next slide. So, one of the key objectives with these systems, and one that draws out some of the unique items, is really this concept of trustworthiness. That's what we're really after in the IoT applications, and that brings security with it, but it also brings in concepts of safety, reliability, and other items coming from the operational domain. And sometimes they complement each other, and sometimes they conflict. And so it does create a little bit of extra work as you move into the IoT domain. Next slide. And specifically when we look at this, I think we've seen a couple different architectures that kind of break out where the enterprise, traditional sort of enterprise fits, including some of the IoT platform concepts, and then down into the edge of the operational environment. And so, the IT aspects, there's a lot of best practices that are out there. The industry continues to have issues now and again, but there's 25 years that have gone into trying to get that right. As we move into the operational domain and new forms of connectivity, things do start to change, and that's where you see some of the items on this slide, whether it's the scale and complexity moving from an IT environment that, at least for the last several years, has been primarily Windows and Apple with some Linux-based systems on the back end, into a large variety of devices, and having to manage those at scale with new architectures, with having to incorporate safety, with having to think about supply chain and brownfield. That's really where the new aspects of IoT come in. Next slide, please. So one of the first considerations, or things that we look at in trying to get our head around this, is sort of mapping through the architecture in a couple key areas. Are the devices that we're working with sensing, or are they actually sensing and controlling an environment? Where are the data and commands flowing within the system? What types of devices are we using? What are their capabilities? What are the environments? And then, from a platform perspective, do we have a single platform? Do we have multiple platforms involved in connectivity down into these environments? Next slide. I won't go through this. It's pretty typical if you're doing security and risk work, looking at vulnerabilities. The only thing highlighting here is that going beyond the loss stuff, there's industry specific information that's out there, and obviously reviewing existing organizational threats is important. Next slide. And then as you start to see this sort of map out, you can see some of the differences, and go ahead and hit the next button, Kathy, please. With some of the threats, so you can see that all the way from the components up through the operational domain, there's potential attack vectors. The important point here is that this isn't static. There's a device lifecycle that exists here. So if you go to the next slide, the devices are moving through these different operational states, from the semiconductors and those manufacturers into the modules, into the devices, and those devices having to be operationalized in a very specific environment, communicating with the gateways and the back-end systems. And so thinking about the life cycle itself and the different actors involved becomes important. Next slide. Which, just highlighting here, as a result of that, there are really two key roles, and some of the attacks we've seen recently actually fall into one bucket or the other. For manufacturers, it's about supply chain integrity, things like secured firmware, software delivery. How do things move through the supply chain? How do we transfer ownership from, say, one manufacturer to another, from manufacturer to the operator? For the operators, it's around securing the data operations and getting that trusted infrastructure, and that's everything from getting, securely automating the device provisioning, all the way to updating and maintaining the life cycle of the devices. One point here is that when given things like predictive maintenance and remote monitoring, the manufacturers sometimes are also the operators. Next slide. Just a couple of references. Keep this simple. This is an older document from Gartner that I'm highlighting here. They've done a lot of things since that. They have their own IoT framework. But this one, to me, was a very easy way to go and get a handle on the key aspects of the project. I think if somebody just got thrown into a program, this is kind of what I would start with to get an idea of what you're dealing with. Industrial Internet Consortium. It's very deep documentation for enterprise architects, security architects, gets into the details of building a security posture for your program. And then NIST, number of documents, once again, from NIST, but probably the key with some of the NIST documents is that they reference back to a lot of industry standards that may be applicable in your given industry. Next slide. We'll skip this one. It just kind of breaks down, what's in a security framework. A lot of these controls people have talked about already today, but once again, as with any approach on the security and risk side, you're going to map from these threat models back in through controls, and that's no different here, although some of the emphasis might be different based on your environment. Next slide. So in summary, the physical operational characteristics are really what's driving the new risk in these environments. It's a good place to go look for what where some of the special considerations are. Use a framework to get started. There's lots of people in the industry working on this stuff. It's starting to mature. It can be very helpful in making sure you're not missing anything and accelerating some of the security work in these projects. And then finally, there's a lot of noise. It's still pretty early in terms of best practices and pulling these solutions together. Really take a look at how much there's a lot of buy versus build discussion out there. There's a lot of using IT security tools, and some of those apply and some of them don't. As well as there's a number of solutions that are out there today that have kind of been bred to solve some of the specific, more unique needs of security when it comes to the edge and operational environments of IoT. And with that, I will turn it back over to Randy.
Great, thank you, Josh, and thank you all. We are almost at the top of the hour, so I wanted to see if folks would be willing to stay on a little bit longer. We had a number of questions that came in, so we'll stick with you if you will stick with us and take a couple of questions that were submitted. Before I do that, if you could just turn to the next slide, Kathy. While I'm talking these questions, I just wanted to highlight some additional resources where you can find additional information. So the first question came in for Shri. Do you believe that PKI certificates will play an important role in securing IoT devices and specifically in connected cars?
So for the first part of the question, I would say yes. I think PKI has been adopted as a standard. I think there are many reasons for that. The reasons are the infrastructure to support PKI is widespread, which is, the certificate authorities, the ability to do certificate signing, generation of keys, and the whole infrastructure and training that's required to do credential management is well understood and widely deployed. So I think PKI and PKI also solves the key problems of device to cloud security that I talked about before. It solves the problem of mutual identification. It solves the problem of device identity, as well as providing a way to actually do the encryption of the channel itself. Now, whether it's going to be used for connected car is an interesting question. I think there are many different uses for that, and definitely in the overall connected car space, we are seeing a few OEMs actually going down this path, and it's actually a very, very interesting approach that they've taken, where they're actually leveraging a private connection to a cloud to allow for proprietary or other diagnostic information to actually go to their own clouds. So it is definitely a key component of IoT device security and device to cloud security, and this is something that's being increasingly being deployed at this point.
Great. Thank you, Shri. Next question is for Steve Hanna. We hear a lot of talk about standards, but what are the leading standards for IoT security?
Well, there are quite a few of them. I'm sure that we've all heard of 5G networks and low power wide area networks. But specifically and they do have their own security capabilities, specifically in the area of security, one thing that I do like to point people to is the IEC document that I cited in the slide, 62443. 62443 includes a great inventory of standards and technologies that are relevant for industrial IoT and increasingly relevant for other kinds of IoT as the threat rises for those as well. So I recommend that one, IEC 62443, as a good starting point.
Great. Thank you, Steve. This next question is for John Neal. John, you mentioned some recent developments with regard to GDPR and other regulations. Can you talk a little bit about what you see in terms of additional government intervention into the IoT space and how government and industry might best work together?
Sure. So right now, I would say obviously Europe and the European Union has been very forward, I guess, leaning with the GDPR regulation and the sort of fines that they've imposed on, I think, Google and other companies for compromising consumer data. The U.S. has not been as intrusive yet, but certainly there's quite a bit of visibility amongst policymakers here in Washington about what's going on in Europe and the impact it's having, not particularly on U.S. companies. And then, again, we saw California sort of step out and come up with their own data law very recently. So I think in terms of the federal government here, there will be some very interest in what to do next. Senator Warner right now has a bill that's been introduced that would basically direct the federal government to only buy IoT related products that were certified. So the language is vague after that, but if enacted into law, agencies would basically have to come up with baselines and standards for a certification. And then obviously with the government's purchasing power, I'm sure that would have an impact on the private sector. Then we also have autonomous vehicle legislation being addressed and security principles around that. We'll see if that gets passed before the end of this Congress. And then we also saw recently the House passed a bill to pilot a smart Medicare card, and we'll see if that gets passed into law. So quite a bit of activity around IoT and cybersecurity in general. And I think the two big things is how fast will the federal government act, and then in what way will any federal government action interact or conflict with state laws. I think it's in everyone's best interest that to building to one sort of regulatory or legislative regime versus 50 plus. So I think the next year or two will be very telling. Thanks.
Great, thanks, John. And we'll take one more question, and we'll leave this one for Josh Jobs. It has to do with identity management and lifecycle management for IoT devices. And how will the device know it is communicating with the correct site, and conversely, the server or the device or the server is communicating with the right device in the IoT world?
Yeah, I think that probably brings in, it points back to a couple earlier conversations. One of the panelists talked about mutual authentication and the techniques that exist there. As you move into this space, obviously the role of PKI and key management, and there are different techniques there too. But I think the way, the mutual authentication aspects of it can be done in different ways. I think those are relatively well understood from an information security perspective overall. I do think you move away from, to some degree, how that's, if we look at the last 20 years, the last 10 years, a lot of the identity access management, a lot of the identity management innovation has been around people, frictionless authentication, behavioral type things. And while some of that applies, what we're seeing in a lot of the best practices and industry standards is that we're going back to a lot of the cryptographic techniques that Steve mentioned in his presentation.
Great, thank you. Well, thank you all for staying with us today and for participating in this webinar. We just changed to the last slide. Here's the contact information for our speakers. And just as a reminder that that today's webinar has been recorded and will be available for playback along with the presentation deck after the webinar has been concluded. You'll receive an email with a link where you can listen to the recording and download the presentation. And please feel free to share this information within your organization to others who may not have been able to participate in today's webinar. This concludes today's webinar, and thank you and have a great day.